In this video, I will show you how to look at this crazy graph and then figure out which one of these four functions it matches. So I'm noticing that all of the options are either secant or cosecant. So remember a couple of things. First of all, please remember that cosecant is the reciprocal of the sine function. Memorize that. Also, you have to know that secant is the reciprocal of the cosine function. Memorize that. So, when you graph a secant or a cosecant function, you don't graph them directly. You start by graphing sine and cosine. So we're going to be actually looking for the sine or cosine graphs hidden in between these peaks and valleys. So the second thing you have to keep in your mind, you have to know what the sine and cosine function look like. So for example, the sine function starts right at the origin, and it goes up and then down and back again. So this is what sine looks like. On the other hand, the cosine function looks a little bit different. Cosine starts off high and it makes this U shape like this. So this is what cosine looks like. Alright, so you have to look at the peaks and valleys. Alright, the tippy tops and the very bottoms, because this sine or cosine function will be running in between these highs and lows. So I'm going to try to draw it. It's going to be something like this. It's very shallow, so it's a little bit tough to draw. But this wavy pattern here is either a sine function or a cosine function. It can be tricky when there is a phase shift. If I ever see something like this, cosecant and then maybe x minus pi over 4, something like that. This is a phase shift. This would mean that the whole graph is shifted to the right by pi over 4. If there was a plus, that would be left pi over 4. But look at these four options. None of them have anything added or subtracted. That's good for us, because that means there is no phase shift, which means if there is a sine function, it's going to start right at 0, 0. If it's a cosine function, it's going to start off up high. So that's going to make it easy to see just by looking right at the y-axis. Before I do that though, we need to talk about the number in the front. Okay? The a value. So these first two functions have an a value of 1/2. That value is the amplitude. So looking at my pink wave here, which is either a sine function or a cosine function, notice that the highs go up to 1/2 of a unit. The lows go down negative 1/2 of a unit. So the amplitude of this graph is 1/2. If you look at the other two options, you see there is no number in front. That means it's an invisible 1. So for both of these, the amplitude would be 1, in which case the highs would go up to 1, and the lows would go down 1. But that's not what happened. So since the amplitude is 1/2, right away we can throw out these two options. So it's just between the first two. Remember, cosecant comes from a sine graph, and secant comes from a cosine graph. So if this is a cosine graph, I'm going to pick secant. If this is a sine graph, I'm going to pick cosecant. So which is it? Well, look right at the origin. I see that this wave starts right at 0, 0, and then it goes up from there. Which one of these graphs starts right at 0, 0? Only the sine function starts right at 0, 0, and then goes up from there. So this wave has to be a sine graph. All right, some version of a sine graph, which means that these valleys and hills must be a cosecant graph, which means that the first answer must be the answer. Let's take a peek. Sure enough, the first one is the answer, but hopefully now you understand why.